Welcome, everyone. Thank you for joining us for our webinar today, 17 Things Developers Need to Know About Databases. This will be presented by Peter Zaitsev, the CEO here at Percona. So we'll begin in just a moment. I want to make sure everyone can see the screen and hear me. So can someone please raise their hand using the hand icon to let me know that you can hear us? Okay, I see a hand. And I'm assuming that means you can all see the screen as well. So that's great. That means we should be just getting ready to get started in just a moment. So I'm going to ask that you have any questions to please save them and drop them into the questions window, and we will answer them at the end of the webinar. We'll set aside about 10 to 15 minutes to address any questions you have. Other than that, you guys are all muted, just so it kind of keeps the noise a little bit down. And we will get going. I'm going to turn this over to Peter so he can get started. Peter, are you ready?
Yes, of course. Thank you. Okay, well, then I guess I'll just get started. Hello, everyone. Good morning, afternoon, or wherever time zone it is in your location. And we'll talk today about the things developers need to know about the databases. And let me start by showing you a little piece of humor which I saw circulating on the social media here about some developers, specifically about the front end developers who supposed to be eating lunch alone because they do not know how to join tables, right? While this, of course, is a humorous piece, I think there is a lot of, the truth in what number of the developers in the modern world may not know SQL, right? And in certain cases, there are certain developers who don't need to, which are not really developing applications which touch database directly, and then that is not that big of a deal. But in many cases, you see also developers working in database directly and have a very rudimentary, if any, understanding of databases, right? Like they don't even know what the join is, right? And how you can use it. Now, another humorous piece which I wanted to plug in is this, right? Today is a very special day for me. I am celebrating my 40 years birthday today. This is one of my friends and this fantastic birthday card. So you are all on mute, of course, but hey, you can still say happy birthday, Peter, to yourself, and let's get on with the webinar. So one thing that I see a lot as I visit companies, what there is often been, let's say, some great split between the developers, which are responsible for writing the application, and their technical operations folks, right? Also, maybe often like as an ops in general, which are responsible to make sure those applications which are which function 24/7. Now, if you look at the operations, you also have some sort of split in this case, right? You may have certain people who are very focused on a database, right? Like DBAs and some other titles can be applied to that. They typically understand database very well, but often they do not look at the or understand the whole picture very well. And then you also have some more generalists, right? People like sysadmins. Often you see people using SRE title for that, which really kind of have a ownership of a whole system, have a great the high level understanding of the architecture, but may not have a very specific knowledge about the database, right? And unless those folks really cooperate very well, there can be a lot of problems to the successful database operations, because guess what, you need both, right? You both need to have a high level understanding to build the highly efficient system as well, right, and reliable system, as well as understand the best practices as they apply to the specific database. Now, if you think about those the devs and ops, you probably have been thinking, as I talk about last couple of slides, well, Peter, where have you been living last 5-10 years, right? There is a DevOps, right, which is supposed to resolve all that kind of problem and tension between developers and operations, right? Now, in reality, those is from what I see, there is a wide variety between organizations about their success implementing DevOps. Some organizations are indeed very good and successful in doing that. Others still run things in, let me call it like a legacy way. And in many cases, people would implement DevOps in general, but it's not really very much applied to the databases, at least certain aspects to that. Like, for example, think about one of the cornerstone of a DevOps as our continuous deployment, continuous integration. It is rather easy to do with code, right? You can deploy the codes, 10 times a day, 100 times a day, and so on and so forth. But the database schema is something which is much more static, right? And you really need to plan and roll it out substantially, right? If you are looking to do alter table, right, to rebuild 10 terabyte schema, that is likely to take some time, and you are not going to be able to do that 100 times a day with absolutely no planning. There is also a lot of risks which are associated with the data, because if you say I deploy with, let's say, buggy code, and you can deploy the new code in a second which fixes the problem, that is not really how things work with database. And if you have did some things with the database wrong, you may take a very long time to undo them, or even have to restore things from data, and sometimes even suffer unrecoverable data loss, depending how your system works. Now, what I think also is interesting, if you look at the large organization, you often have this what I call like conflict between ops versus ops 2, right? Let's say some different focus which are focused in the operations, which may have their needs and agendas, right? In many organizations, I would find there is a group for DBAs, group for, let's say, sysadmins, so infrastructure engineers. There may be kind of another storage group which is focused on the storage, and then there is also like a security group, right, which is focused on making sure everything is secure. And then if problems happen, then often everybody kind of points finger at each other, and due to that lack of cooperation, it may take much longer time to resolve the problems with the databases. So if you want to go back into the ops and devs conflicts, like in a lot of cases, I see the tension which can be articulated this way. From a developer standpoint, they can say, oh my gosh, why is this kind of a stupid database is always a problem, right? I run almost the same query, right? I don't think there is in particular much different with that, but one of them takes a couple of seconds, and another takes minutes or hours, right? And all I have is slightly different where clause. Why can't it just work predictably, reliable, and always fast, right? From ops standpoint, right, especially which DBAs, like we understand the database well, it's like, oh my gosh, why do you not learn schema design, right? Some schemas which developers may come out from Protos for random Googling can be absolutely bizarre, right? Why don't you write the queries which are reasonably optimized or at least run explain to understand if that query is optimized enough to put in production, right? Or why don't you think about the capacity planning? Because in reality is, as you provision the database, it will have certain capacity, right? Ability to handle a certain load and not more. There is nothing as a unlimited database capacity out there. Now, if you look at the single outcome from this first session of my webinar is what if you look at the database success is really the shared responsibility. And if you really want to make sure you have the database power application which is efficient, performance, it has no downtime, this is the ultimate which is a shared responsibility between your developers and operations team, right? And that needs to be understand this way, right? Simply kind of throwing the shit over the wall, right, and having the DBAs team to take care of it, or just blaming the developers for all the problems which exist in the database world is not going to provide a successful outcome. Okay, with that, let us move to some top recommendations for developers in particular. So one is you really need to make sure what you learn with a database, how a database works, right? Because you can't really just treat a database as a black box which is completely unknown if you are writing the applications of any significant complexity, right? Any significant scale. Specifically, I would suggest to make sure you understand at least the basics of a schema design. You understand the power of a database language, and you also understand, okay, if I send that query to a database, what really happened, how a database executes that query, because that will help you to understand what are the good queries and what are the bad queries, right? And how to make bad queries good queries. So if you look at the relational database in particular, this is example of a schema design, right? As you can see, it contains from a bunch of tables which have relationships between them. One of the interesting thing when it comes to the schema design is one of the approaches you can often follow is to look at the design which come from a kind of entity relationship modeling tool, right? Or you may have even object design driven by ORM or in your programming language, right, which will map that to a table. This is often very good as the draft, right, as initial schema, but you often want to tinker that and optimize it, maybe change layout of a tables based on the purpose that schema is going to solve, right? Specifically what queries it is going to serve, because depending on the queries, one schema may be more optimal than other, and often you have to make some compromises, right? And change the schema from that perfect textbook design to get a meaningful performance, right? Like maybe you duplicate some data, denormalize, right, some tables, and so on and so forth. The second thing, as I mentioned, is you want to understand the query execution, how it works, right? And this is example in the MySQL how queries are basically executed. Right. I think what is interesting is if a lot of developers, right, for if you are MySQL expert, this will probably look at something as a super simple, very high level to you, right? For a lot of database users, developers, often they do not have even this kind of understanding, right? What actually you have a query which is being parsed when it's run through a optimizer which come up execution plans and executes the query. Again, very high level, but that is a very good to make sure what you understand it. Now, I also mentioned you want to understand the power of SQL language, and why is that important? Because if you run the if you don't understand the SQL, you may really treat your very powerful relational database as something as a key value store and work with very rudimentary operations of it, which will be very inefficient both from a developer productivity, because essentially you will have to implement the SQL in your application for a lot of things, right? But also because that is not going to be very efficient for a database if you send a lot of trivial queries to that compared to small queries. But at the same time, complicated SQL is also very harder to get right? One mistake doing a join with no indexes, and you may have a query which takes days to complete, right? Or even maybe not will complete in your lifetime. So you have to be very careful here. One interesting story I have here, I remember coming to the customers like probably more than a decade ago by now, and they told us, look, I mean, we have taught our developers about how to use MySQL successfully, and we have just 3 rules for that. I would tell them, well, wow, that is very interesting. What are those just 3 rules, right? What are those? And they tell me, well, it's very simple. It's no joins, no joins, no joins, right? And in their case, they really essentially gave up on having developers to learn to use full power of a database, and really treated MySQL as a glorified key value store, right? And they are not alone. There are a number of companies in the Silicon Valley which went through a similar route, and it can work, right? And you can build large-scale application of that, but that is not the most effective approach. So how do you know what queries are good queries and what are bad queries? Well, the fantastic way to do that is to make sure you run explain, right? And learn what explain is. Here is the link to the MySQL manual, right? Because I can probably do like 3-hour tutorial on explain alone, right? There's a lot of methods there. And this is also the visual diagram, which is from MySQL Workbench, right? This is a wonderful tool if you want to visualize your queries, right? Which is kind of maybe easier to understand compared to the textual output from explain statement. You can do that. Another thing I would point out about explain, it's a good idea to think how explain may change as your data grows, right? Especially for an application where data change is likely to change dramatically, because many applications are launched when you have essentially empty database, right? The very small ones. And in this case, queries run fast, explain look good, but when you actually get that to a production scale you're expecting, your explain may become, the same explain, just with different cardinality numbers, right? Different rows and tables may become quite ugly, right? And you can do a third experiment to see how explain may look with a larger scale table, or in many cases you can just populate the test database with a large amount of data and look at that. Now, if you're looking for some more advanced tools, I would recommend the tool PMM, or Percona Monitoring and Management. It really provides a lot of insights in terms of what queries are causing the load on database, which are the slowest queries, which are doing some nasty stuff you don't want to do them, like creating temporary tables, of course, with massive sorts and so on and so forth, right? Or examine a lot of rows. You can do that with PMM. You can also find why exactly the given query pattern is causing the load, right? So, like, say, for example, if I if I look at this at this at this query, I can see is what this query doesn't spend a lot of time on disk IO, right? Just 3%. So optimizing that query would not be their the big problem, right? But every query has to do an external sort, right? Also log as a file sort, which is typically impacts performance negatively, right? And also what to do about them, right? How to improve their performance. In this case, we provide you the information about the example of this particular query, as well as create table and explain for a given query. So you can really see all that data on the same page and hopefully get some insights about what indexes you should add or how you can modify the query in a different way. If you want to check out PMM more, you can do that on the pmmdemonpercon.com. And we now have a version 2 PMM v2 as generally available, right? So it has a lot more advanced features, especially when it comes to query insights compared to the first version of PMM. Okay. The next thing you really need to understand is how queries are executed. And I think this is, again, where some disconnect can come with the developers, right, who really think about the database as a black box, right, and somebody who are experts with a given database technology, and for them that is very obvious. For example, it's very common for me to see developer and say, oh, you know what, I have my, let's say, MySQL running, right, with replication, one master and 3 slaves, and I am, running some very complicated query on it, and for some reason I see no usage on all of those servers, and my query is really running very slow. What the hell is going on out there? The expectation may well be, well, you know what, I have a cluster of servers, I send the query, and I expect a smart database technology to really figure out and utilize all of those resources, how to really serve my query, right? And in many cases, like or in some database cases, especially the more modern cloud-based system, that is exactly how it happens, right? I mean, if you run a query on the Google BigQuery, for example, it will be very fast because you don't even know how many resources Google use concurrently to deliver that, right? Or if you look at the some modern technologies such as a ClickHouse for data analytics, right? It's also will be able to run query in a parallel, in a distributed way on the on a whole cluster, right? That's may not be reality of some other systems. Let's think about the single node. Single node, that is, for example, how Postgres is able to run the queries. Postgres has the parallel query functionality, right? So if you run the complicated query and the optimizer designs, it makes sense to run more than single CPU core to execute that query. You may have multiple cores used, but you're not going to get replicas used to serve the same query in Postgres. And finally, if you look at the MySQL has a single threaded query execution. So single query is run only by one thread, right? And if you have I don't know, like say maybe up to 100 or even more than 100 CPU cores, which are available those days, guess what? The rest of them will stay unused, right? And again, in this case, as a developer, it's very important to understand how their query processing happens, so you can avoid pushing the queries on the system which it cannot serve, right? And when you redesign those queries, or maybe move them to the technologies I mentioned, which are better designed to process those kind of monster complicated queries much better than MySQL, right, or other databases which are not really designed well for that. The next thing is indexes. If you look at the indexes, of course are absolutely must for optimal database performance, but they are also quite expensive, right? And I think it's important to consider both, right? Because I know a lot of developers have very simplified view here, saying, well, you know what, I read a lot of tutorials and they tell me, you know, if things are slow, add indexes, like, or something like, oh, every single column which I see in a where clause should get an index, right? All of those strategies, they can create in a lot of indexes being created, but poor index strategy. Another thing which often comes out from that index strategy is what you see way too many indexes created only on the single column, right? You pretty much can see the schema which has almost every column indexes, but not multi-column indexes, right? Which is another kind of giveaway from for me for schema which was not optimized, indexed very well. Now let's talk about the index is expensive, right? Why indexes are expensive? Well, if you think about that, when you are adding the data in the table, it actually has to be stored in the data itself as well as in every single index. And in well-indexed tables, updating those indexes, right, when you modify the data, can actually be 80% or more, right, of a total execution time, right? So that can take a lot of time and slow down your inserts, but it also impacts the read performance as well. Why read performance is impacted? Well, there are a couple of things here. The first one is the more indexes there exist, the more work the database optimizer has to do to pick the indexes which are optimal for executing this query, which can take a lot of time, especially for more simple queries. The second reason is as you have many indexes and larger data size, you will have less portion of that data fit in your cache, right? In a database cache, hence reducing performance. So if indexes, you want to make sure you have the indexes you need, but you are also being very careful in adding the indexes which you do not need, right? And as your application evolves through years, remove the indexes which are no more required, right? That is another kind of mistake, but as you change your application, change your queries, there may be indexes which are never used, but they are never taken care of and removed. Next thing is a capacity planning. As I mentioned in the start of the presentation, is no database can really have an unlimited scale, right? And even those kind of cloud databases, you know, DynamoDB, right, and Cosmos DB and what's not, right? They do have a limit. And then they say, hey, you know what, we have unlimited scale. Then that pretty means they hope that you're not going to put more load on it when they provisioned infrastructure on the back end, right? Now, something what is also important to understand was scalability is very application dependent, right? And what the numbers you may be seeing somewhere is typically marketing numbers, which is so in the best case scenario, right? So for example, if you go out there and talk to folks doing, for example, Google Spanner, right, or some other massively parallel cloud database, and ask them, hey, can your system handle 2 million updates a second? And they can say, oh, sure, 2 million updates a second. That is absolutely, you know, trivial, right? Not a problem at all. And then you add them, oh, I want to have those 2 million updates a second for a single row from multiple locations. And they say, oops, that is going to be a problem, right? And in reality, because synchronizing all updates on a single row, right, is a very different and much more complicated problem to scale than having kind of writes to the different data sets, right? Now, reality in this case is, of course, your application is very likely to be somewhere between those kind of worst case scenario and and the perfect kind of super optimized application which is shown to derive marketing numbers. And what that means is when taking the scalability decisions or measuring how far system will take, you want to make sure to do your own measurements and trust them rather than just vendor promises. What you also want to understand in this case is when you are looking for certain performance, can it be done or can it be done efficiently? And efficiently first and foremost for your budget. Like one term not coined by me but by somebody else about a cloud vendor in particular is they're the most optimal approach, the most preferred approach to tuning is a tuning by the credit card. So that means if you're running the, let's say, some database, your first suggestion, and if something is slow, your first suggestion is to go to the larger instance, and then another larger instance, and so on and so forth, right? And you do not really kind of force to think about how efficient your load is. But when you do that a few times, and then you are dealing with a database which is spending you money probably 10x than more optimized database should be, right? And that is why I always encourage to think not only about wherever current architecture and a system can give you performance you're looking on, but if it is going to be efficient to your wallet, to the environment, right, and so on. And I think to understand, which is interesting, is approach to scaling. If you think about the scaling, there are two approaches, right, on a very high level. It's vertical scaling, right, when we add more and more hardware, and horizontal scaling, right, when you have many kind of many different kind of smaller databases, right, running smaller hardware pieces. It's often referred to as sharding. In reality, these are your choices. In many cases, you do both, right? Like even with scanning logically, in many cases, people run relatively large shards because dealing with 10,000s of 1 gigabyte shards, right? If you need 10 terabyte database is impractical, right? And a large and truly large amount of shards, right? That's creates whole another set of problems, right? If you really have to manage so many of them, right? So in many cases you have to deal with them with both. Now another interesting thing in this case is what you will see. You will see their vertical scaling. It's often have a bad rep. It has a bad reputation because, well, you know what? If you really want to build something like Facebook, you cannot run it on the same server. Yes, that is absolutely correct. But there are not as many applications in the world which really need a Facebook scale, right? Or even a scale which is, 1,000th of a Facebook scale, right? I mean, how many applications have many millions of users? Many web applications are, but if you look at a lot of enterprise applications, they are often built for hundreds of thousands, maybe tens of thousands of users, right? And those applications in many cases can do very well with a vertical scaling, right? Even not going to particularly big iron. So you really need to make choices what is right for you here. Another thing is a difference between scalable and efficient, right? These are not the same thing, and there are certain things which will be scalable, right? Which can really go to very high the system size if you need to, but are not really efficient, right? So, for example, this is a TiDB, right? Like a massively parallel MySQL replacement, right? You can see in this case, if you run a single node, it is actually quite scalable in terms it's being able to use multiple CPUs on that node to execute the same query, right? And it really gives you much better performance on that kind of on that big iron, where MySQL really really doesn't, right? It doesn't really improve that much specifically. But at the same time, if you think about the efficiency, in this case, we are driving many simple queries which scale very well, even with MySQL. We can see what this system is not as efficient doing that work as a MySQL, right? In some cases, being 10 times less efficient, while at the same time, multiple times more scalable than MySQL, right? That is just an example, of course, and the things will vary between different systems. Another thing is understand what the throughput is not latency, right? So in this case question, does a 10,000 queries means that this system is fast? Well, you can come up with this example. Let's say each and every query takes 1 second. So that's relatively slow query by modern standard. But I have a system which has 10,000, 100,000 connections, and it executes 100,000 of those queries in parallel, right? The throughput will be 100,000 queries a second, but the latency or response time for query will be still a very slow of 1 second, right? Why is that important? Well, because of course, this is kind of like an exotic example, but especially when we're working in the cloud, we often talk about the throughput for our storage like EBS, right, or some other things, right, which indeed can reach a very high performance in terms of throughput, but they do need a very high concurrency to do that, right? And the response time may not be what you think it is, right? Especially when it comes to things like network latency. And latency, that is something which another piece which needs to, which I think needs to be understood pretty well. Like this is not particularly relevant to the databases or has anything to do with database, but I think that is a fantastic diagram to really to put the different latency in the perspective. And I have a link here, even which has this on the website where you can really see how those numbers have changed through the years, right, for the last couple of decades. So you can really see how some things latencies have been really improving a lot, and some of them have been staying relatively static. One of the things which is relatively static is speed of light, right? So why speed of light is important? Well, because what I have seen with a lot of developers, right, especially like if managers, they would like to have this kind of a magic database where you can write the data in any place in the world. It's has a synchronous replication, right? So data is instantly replicated throughout all locations in the world, and it has no data loss, right, possible. In reality, that is doesn't work quite this way, right? Because of speed of light, the limitation, and you often need to understand that when you are planning for your high availability scenario, right, as well as your disaster recovery scenario. Right? Like, for example, one of the big no-nos, which is a very easy way to kill your database performance, is running your database in the cloud in a different region than your application, right? Because when you're going to pay that increased latency for every database request, and you may have tens of them for every user request out there, which tends to add up. Another mistake which I have seen people making is talking about the network bandwidth as it is the latency, right? Like, so for example, if you say, hey, I have those kind of two locations and there is a 10 gigabit network connection with them, well, that is available right now with between the points, which are many thousands of kilometers between them, and that will make the latency quite high, even if the bandwidth is high. So what you also want to understand here, what the connection they add latency, many small queries add latency, and especially it's important to test those things because the latency numbers on your laptop, which you may be using for testing, may be very different from the real world, right? Even if you operate within the same data center, right, or availability zone. I also like to sum it up as a law of gravity when it comes to databases, right? When you have a really shitty application, right, at scale, it will bring down any database, right? Again, remember, we both need the DBAs and developers to work together. So both the database is solid, well-tuned, right, as well as the application is reasonably optimized. Another some practices is what you want to make sure what the developing and testing you have access to a database of a production-like size, because developing a toy database is the easiest way to have the queries which are absolutely non-scalable. And remember also, right, that queries do not scale linearly. You may have the queries to become, especially bad queries, to become, for example, 100 times, 1,000 times slower when your data size increased only by 10x. Another related thing is to understanding memory versus disk, right? And many small databases additionally will have an effect that they all fit in memory completely, and memory is much faster than disk. Even right now, right, when you have SSDs, right, still SSDs are much more than accessing memory, the data directly in the database cache, right, in this case. So that is another testing you need to make sure, and make sure what you are testing with a case which is relevant for your production. Now, if you look at another practice which is kind of more operational, is what you need to know, what a newer is not always faster. And that applies to the hardware, that applies to the software, both on your operating system size, right, as well as on MySQL size, right? So for example, with every major MySQL upgrade, which I have the most familiarity, is there are going to be some cases which the queries run slower, because execution plan changes, or because maybe defaults were changed because maybe to more safe ones, or maybe something else. So make sure what you are you're testing that, and not doing what we see a lot of people doing, just upgrade it, hope for the best, and then come and say, oh my gosh, now my production kind of starts to fall apart, right, when I get in the in a peak period, right? Another thing I want to point out, which we see a lot of problems, is the upgrades. If you think about the database has this the end of life process, right, which is important to take in account, especially for long-lived applications, right, which live many decade or more. Because in a lot of cases, the database upgrades may require some application changes to deal with some features which have been deprecated, or maybe with some small behavior changes, different optimizer behavior, and so on and so forth, right? You want to plan for that, and yet in many cases development teams are kind of completely moved on, and then they're saying, hey, you know what, I want to upgrade from a PostgreSQL 9, which is end of life, right, to at least kind of PostgreSQL 11. The folks may not be there to do that, right? And without support of developers, it's very hard for just operations folks to do a database update, which they must do if nothing else, right? Because of the compliance and kind of making sure that all security holes are fixed, right? With our developer support. Another specific issue I would mention is the character sets. because character sets have significant performance impacts. Also, if you set a character set, it's very pain to change because that typically means logically rebuilding the data indexes. And also, if you are using a wrong character set, like for example, Latin 1, and you're stuffing UTF-8 data in it, you can have a irreparable data loss, right? It also can change performance a lot, right? So for example, I mentioned MySQL 8 often can be found having lower performance than MySQL 5.7. But a lot of that comes because default character set in MySQL 8 is UTF-8, while it was Latin 1 in MySQL 5.7. Now, in a modern world, guess what character set you should be probably using? Well, UTF-8, right? Because even if your application is focused on on the region with where Latin characters is good enough, right? I mean, everybody is using emojis those days, right? Even in a kind of casual conversation. And guess what? Like emojis, UTF-8, right? So here is example of our impact of UTF-8 versus Latin none of MySQL 8, which you can say it's much less. Next thing to cover is the operational overhead. Right. I think a thing you want to consider here is that the operations takes time, money, cost, overhead, right, in this case. And you want to make sure that is planned in a capacity planning. I have seen so many tables which kind of run okay when we run, but nobody is able to do anything with them, saying, oh my gosh, even if you try to do a backup here, it's all kind of greens to hold, right? And that is a very bad situation to be to be in. Distributed system. One thing I will say about the distributed system, of course, this is reality right now, right? And in many cases, they offer much higher scalability and havability, but they are more complicated and have many more failure scenarios. What that means is you need to make sure you invest in your application testing in relationship to that distributed system. I have seen so many cases when the downtime was caused or data corruption happened because application has different ideas about what happens during that distributed system handling of a failure, right? And it is not always completely transparent to application, right? As you may want to believe as application development. Automation. That is another trend of the last decade and more, right? We are using a lot of automation those days, because without automation, just manually, we cannot really manage the many instances, right? Tens, hundreds, right? Sometimes thousands we have to deal with. But also automation, it gives us ability to really make mistakes and destroy databases at scales. In so many times I have seen people say, oh, you know what, we just had this kind of test script, we plan to run it in development, it was run in production, and now, oh my gosh, it's very hard to repair damage done, because guess what? While there was automation, there is no automation written out to undo that mistake which was done, right? So the best practice in this case is to make sure what your automation scripts, right, for deployment, right, or other actions, they pass at least the same cadence of process as your main code. Because in many cases, I see the very specific requirements for code reviews, for QA, when it comes to your product. But the automation tools for deployment, that could be just one development implemented something in Bash with no tests, no code review, right? And it's just pushing the production, and that is a very dangerous. So, and the last thing I want to mention is, of course, the security. Again, security is a very deep topic, right? You can have many presentations, right, for many days talking about how to secure your database, prevent database injections, right, enable encryption in transit, at rest, right, and so on and so forth, right? But one thing you want to also to know here, what that is another piece when it's a shared dev and ops responsibility, right? Neither of a team is able to provide the full set of a database security on themselves, right? And they should not be trying to. Well, with that, it's all I have, and now I'm happy to take some questions if there's any.
Thanks, Peter. So yeah, anyone, if you have questions, feel free to drop them into the question window, and we'll get them over to Peter. Let's see. Do you have plans to support TIDB at Percona?
Yeah, so at TIDB, we are looking at this technology, right? It is very interested and exciting. Currently, we do not have plans for supporting that directly, but it's all based on a customer demand, right? So if you're Percona customer, I would encourage you to relay that feedback to your customer success manager, so we can gauge the interest of supporting this technology or any other technology better.
Okay, thanks, Peter. We had another question come in. If I am using MySQL 8, can I move to Latin character set? Since
well, yeah,
it improves the efficiency.
Oh, well, first of all, in MySQL 8, there is a significantly less performance difference between Latin 1 and UTF-8. And in MySQL 8, default change, but you can change back default, right? By setting default character set to Latin 1 in MySQL 8, you can do that. And also, as you create specific tables and even kind of specific columns in tables, you can specify Latin 1 character sets for them if you do not need UTF-8 handling for them.
Okay, great. And then we had another question just come through, which is, what is the biggest mistake developers make because they don't understand the database?
Oh, well, I think the one I see very often is some mistakes or typos because developers may not understand the SQL or they probably care, right? So many people would have, for example, update, table XYZ, like set, I don't know, say password equals X and forget where clause, right? And that goes ahead and updates all the data in the database, right? Which is kind of very painful. But funny enough, this problem was so common that the MySQL in its early days implemented the command line option for MySQL command line client called IAMDummy, right? To really help you to prevent this mistake, right? It simply would refuse to run update or delete statements without a where clause to help you to protect from that mistake.
Great. All right, well, it looks like all the questions that we have for today. So I want to thank you guys for coming, and happy birthday, Peter. I hope you have a great day. I appreciate you taking some time out of it to celebrate and host this webinar for us.
Okay, yes, thank you. Thank you
welcome.
everyone for attending. Have a great day.
Bye, thank you.
Bye.